This is the aeroplane simulator. We can simulate and control the paper aircraft from a web page on a mobile phone. The aeroplane can pitch up and down. It is powered by a servo motor and controlled by Arduino Uno. This is the CAD design of the airplane simulator. Here, you can see the paper aeroplane being placed and balanced on a single point of contact. We have chosen a pencil because it will act as a point contact for the aeroplane, allowing it to perform pitch, yaw, and roll movements. Alternatively, we could have used a spherical joint. At the back side, a link connects the aeroplane and the arm of the servo motor. As the servo motor moves its horn, the aeroplane also moves with it, performing pitching up and down movements. Let's understand the concept of an aeroplane simulator. This simulator will simulate the actions and movements of an airplane when given certain inputs. In this part, we will focus only on pitch control, which involves the airplane moving up and down. This is the circuit schematic of the flight simulator. Here, we can see a servo motor connected to an Arduino Uno. For now, we are focusing only on pitch control, so we have used only one servo motor. The electronic components required for this project are an Arduino Uno, a servo motor, some connecting wires, and a power supply. Here, we can see the aeroplane demonstrating pitch movements automatically. This is our first prototype where we have assembled all the hardware components together according to the CAD design. We can clearly see that the aeroplane is pitching up and down. Currently, we are not actively controlling the servo motor. It is set to move its arm up and down repeatedly. This prototype is solely to verify the integration of all the mechanical and electronic components together. This is our second prototype where we have made some improvements. In this version, we have replaced the paper aeroplane with a different setup. Unlike the previous prototype, this version is controlled remotely using a mobile phone through a website. Let's understand the concept of the entire setup. First, we have a mobile phone where we open a custom-built web page. On this web page, we have buttons similar to a joystick controller. The mobile phone is connected to a local area network via Wi-Fi. Additionally, a laptop or computer is connected to the same network. A Python-based Django server is running on this laptop. Whenever a button is pressed on the web page, the button's name and position are sent to the server computer. An Arduino Uno is connected to this computer via a USB cable. When a button is pressed on the web page, the signal is sent to the server, which then forwards the signal to the Arduino Uno via USB. The Arduino Uno, in turn, sends a signal to the servo motor connected to it at digital pin 9. The servo motor moves its horn, thereby moving the aircraft. This is how the aircraft performs pitch movements, up and down, whenever a button is pressed on the web page. Let's verify this concept. When we click on the button on the web page, the signal gets transmitted to Arduino Uno. So we can see the RX and TX LED blinking, which means our signal is getting transmitted. And here we are turning on and off the built-in LED through the web page. So our concept is verified and working. Now let's try the same thing with the web page on the mobile phone. And we have added the logic in the code to rotate the horn of the servo motor if the button press is detected. Here we have the web page-based controller in action. When the up key is pressed on the web page, the airplane pitches down. Conversely, when the down key is pressed, the airplane moves up. The web page provides real-time control over the pitch movements of the airplane, that too through a web page in real time. This web page can be opened on any device and doesn't require the installation of any application. This is the third prototype or version of the project. We have made significant improvements and refined the code, resulting in a much quicker response from the motor. The refined motor speed enhances the overall performance of the aeroplane simulator, making the pitch movements more responsive and precise. This aeroplane simulator can be controlled from anywhere worldwide with just an internet connection. This opens up various possibilities for future applications. The project can be further enhanced by implementing additional features such as roll and yaw control, incorporating sensors for more realistic simulations, and integrating feedback mechanisms for enhanced user experience. The airplane simulator can also find applications in pilot training, aviation education, entertainment, and research. Its remote control capabilities make it a versatile tool for users to explore and learn about aircraft dynamics and control systems. The project has the potential for further advancements and can be adapted to various scenarios, making it a valuable tool in aviation and flight simulation. That's all for now. See you again with more robotic technologies. Robotics every day.